Good evening, students. Today we'll start learning about the moment of inertia of triangular lamina. Moment of inertia of triangular lamina. Okay, the triangle is having a base B and height h. Okay, moment of inertia is also called as second moment of area. Keep in mind, second moment of area. It is nothing but area into square the perpendicular distance. Okay. Now, to start with, we'll understand the figure at first. This is the lamina, triangular lamina, base B and height H, or it can be taken as D. Okay. We'll consider a lamina, strip, elementary strip of thickness dy, width of B1. Okay. This strip is at a distance of y from the lower surface AB, and the remaining distance will be d minus y because the total height of the lamina is d, and therefore d minus y. D minus y is the remaining height of the triangle. Okay. Now the first question is, it is as similar to the rectangle. Here also we'll consider the area of the elementary strip. So area of the elementary strip, we'll be considering it as a rectangle form. Though it is an element strip of a triangle, we'll consider that as a rectangle, as dy, the depth, into b1. But what is b1? What is b1 is a question. So how to determine b1 from the similar triangle concepts? So this I'll consider triangle 1 and the whole as a triangle 2. Okay. So I'll write it as b1 by b is equal to height of the triangle of this triangle 1, d minus y, by the total height d. So therefore, what is b1? I get it as b by d into d minus y, or I can write it as b into 1 minus y by d. Anyway, you can put across. So you can write it as anyway you can put across. So b into, so therefore area of the elemental strip, or area of the strip is equal to, which was dy into b1. I can write it as this form, right? So dy into, in place of b1, I'll write it as b by d into d minus y. Okay. Now, similarly, such number of strips will be available throughout. Right? Here we are calculating the moment of inertia of the lamina. Correct? So now, this elementary strip is at what distance? At a distance of y from the AB. We are taking about AB. Okay? We are calculating the distance, or calculating the moment of inertia of the elementary strip, about AB equals moment of inertia. What did I say? It is, the definition is area into square the perpendicular distance. Area of the strip we have calculated as b by d. into d minus y into dy. What is the perpendicular distance? Y square. Okay. Y square is the perpendicular distance. As you can see in the diagram, it is located at a distance. This here is a strip located distance of y, right? So therefore, I can write it as, I can split over as b into dy into y square minus d by d into y into dy y square. Okay. So when you do all the simplification, you'll be ending up with this equation. Further, you have to integrate. What are the integration limits? It will, because the height of the lamina is 0 to d. 0 to d, you have to give an integration 0 to d. Further, when you integrate with the limits, you will get the expression equal to bdq by 12 about IAB. But now I'll be applying, I want IXX. So I'll be applying perpendicular axis theorem. Perpendicular axis theorem. So which is given as AB is equal to IX bar plus AY bar. So I'm supposed to calculate IX bar. I know IAB. I'll be substituting, and area I know half into B into D. What is the perpendicular distance for that? 1/3. 1/3 of D, because it is from the base of the triangle. It is from the base of the triangle we are measuring. This is 1/3. From the apex, it is 2/3. So when I substitute, I'll get it as BDQ by 36. So similarly about YY axis, I'll get it as DBQ by 36. Okay, students, with this, I'll end the session. Thank you all. Thank you.